So sorry for that break. So these are the predicted price. This is the predicted price for each of the instances we entered. Let me go to that code back. For each of the instances we entered, let me show you the data set. Yes, so we entered a new instance. Let me show you in the code. We entered a new instance, 100 and blue, 200 and red. So it's just the same thing as entering a new instance, 100 and blue. Then we enter the next one, 200 and red, and like that without entering the price. So this data is going to predict the price. This new data we've provided is going to predict the price. Yes, based on the former data that we provided it with, the patterns it has learned. So we can see that from here, the predicted price for 100 and blue is 201. Yes, 266 and 280. So now we move to this one. Let me show you the second example. This is size to predict price. This is just one feature, size, and one target, price. So we are going to enter new data here. After, take note of the libraries. Take note of the libraries I use, because we are going to plot a graph here. Take note of the libraries. We are putting this whole data in a data frame. Yeah, it will be well arranged. Then we are separating, just like what we did last, separate the size from the target. Separate the feature from the target. This is the regression. This is the model. This is the training. This fits the model, is the training. This is the new data now. So now we have noticed that from this data of size, the more the size increases, the more the price increase. So we are going to supply it. You can see the more the size increase, the more the price. So we are going to supply new data, expecting increase in price. So you can see something like this now. You can see something like this: 13, 15, and 18. So this is we make prediction after the new data. This is the prediction block here, and then we are going to print it. So all these codes here you see are for printing is to print the predicted values. This is the coefficient, which I'm going to explain later. Don't worry about that. This is the plot. This is a scatter plot to show you the point where it is predicted to, the point where it has predicted. So I'm going to show you. Let's run it right now. Yeah, so you can see from here. So the one of the new data we entered was 1300. You can see what it has predicted. The more the size increase, the more. This is the actual data. These are the actual data. This one here, this is the actual data we use to train. You can see from this graph, this is the regression line, and now this X is the predicted data. So the next one we produced was 15 to predict 500 and something. The next data we put was 1800 to predict this. You can see what's going on here. So you can see that it is accurate. You can see that it is accurate when you check this predicted price. You can see that it is very, very accurate. Look at the price here. For 1300, 450 something. You can see that it is really, 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 really accurate. So yes, that's what it is all about. That is linear regression. So the next one will be for testing data and testing and training. We are going to be splitting this data so we can use those metrics, the metrics I earlier told you. I can explain the metrics to you. So for this testing data, take note of all the libraries. You will need these libraries. Yes, because we are still going to plot the graph. And this is the data set we are using, lean.csv. So let me show you lean.csv. Size to predict price, size to to predict price. Lane.csv. Let's cancel this guy. Yeah, so this is what we've done before. Define the features, independent variable, split and test the data. Now let me explain this part to you. Splitting the data means you are going to split this data into two. So it's used majority of the data to train and minority of the data to test. So this is, so it can take this part of this size of the data to train it, then it will use this size of the data to test it. So how, let me explain how that works. When it trains it, it will take, it's going to discover a pattern for itself. And now when it finally trains it and tests it, when it's testing, it's going to use this side of the data, that is 0.2. That is 20% of the data. That's why you see 0.2 here. Test size 0.2. We can make it 0.3, we can make it 0.5, but I think 0.2 is the best, so that it will use majority of the data to train and minority of the data to test. So when it's done testing, when it's testing, it's going to actually take this part, this size part, this price, the target part, as if it doesn't exist, like it doesn't exist at all. So anything it predicts and it matches the actual price of this target in the data set, it has passed the test. And that's where you see it in the metrics. So let's go there. So we are splitting this. So this is the algorithm. This is actually the algorithm, the format and everything. We use standard scaler. Yeah, I'll explain standard scaler later. This is the model training. This is the model definition, and this is the training. After training, we make prediction. You've been seeing this in the past. So this is the algorithm for it. So now let me explain the metrics now. So the metrics is the most important metrics is this R squared. R squared. So if your R squared, if you have an R squared of 1, that's 100%. That's perfect. That's totally perfect. If you have an R squared of 0.9 something, it's totally perfect. But if you have below 0.9, you still need a little work to do. So this is our plot. We are going to plot the graph, visualizing the result. So let's run it. Yeah, this is to tell you that it's actually almost perfect, because this line, if you see this line almost matches with this line. This line is not that far, it's not very far. But if it was something like this, that would have given us 100%. It was something like this. So we just have a little bit of inaccuracy, but it's almost perfect. That plot and histogram, we don't need those ones for now. But that first one I showed you is the perfect one. For histogram, that one you saw, and the other one I cancelled. I have it in the next, in other models, of which is very important. So you can see the R squared here, 0.999, which means it's almost perfect. The model is perfect. So any new data you are going to put is going to work perfectly fine, perfectly okay. So that's it for linear regression. Thank you very much for watching. Stay tuned to the next video, of which I'll be discussing polynomial regression. Polynomial regression is more flexible than linear regression. So stay tuned. Thank you very much.